Hello everyone. So in this video, we'll talk about naive-Bayes classifier. So actually, naive-Bayes classifier is a supervised learning technique. Okay. So supervised means whenever you have a data, the data, you know, with a label data, right? So we want to build some model for this particular target. So let me show you one data. Here you can see there is a data. So there are some feature and this is my target and I want to build a classifier for this, predict the uh, basically the classifying the data, right? So here you can see this is a string value. So let me first convert into the numeric value. So for that I'm using the label encoder technique. So here you can see I'm able to convert into the numeric value. So if you write a value count here, you can see I have three category. One is 0, second is 1, third is 2. And every one I like similar number of samples. So total 150 sample and like all three has the same amount of sample. So basically we need to build a classification model. And in this video, we'll try to implement naive-Bayes. First, let's try to implement naive-Bayes using scratch. Like we'll write a Python code and try to uh, build a naive-Bayes classifier. So let's first discuss how naive-Bayes classifier work. So actually it's a probability technique, right? So in our data there is three class 0, 1 and 2. So basically, and in our data there are four features: feature 1, feature 2, feature 3, feature 4. So basically here you can see there are four features and this is the target. So what we'll try to do, we'll try to calculate probability. Okay. So like probability of, you know, 0, probability of 1, probability of 2. So 0, probability of 0 when feature 1, feature 2, feature 3 and feature 4 is given. Similarly, probability of 1 when feature 1, feature 2, feature 3, feature 4 is given. And probability of 2 when feature 1, feature 2, feature 3 and feature 4 is given. So we'll try to use Bayes theorem. In Bayes theorem, if you want to calculate probability of A given B, so the formula is probability of B, sorry, probability of B given A multiply probability of A divided by probability of B. So this is basically the Bayes theorem, and we'll try to utilize this Bayes theorem here. Okay. So let's try to open this according to this. So we need to calculate probability of 0 given feature 1, feature 2, feature 3 and feature 4. So if you open this, it looks like this. Probability of feature 1, feature 2, feature 3, feature 4 given 0 multiply probability of 0 divided by probability of feature 1, feature 2, feature 3, feature 4. Now, even for if we calculate probability 1 given feature 1, feature 2, feature 3 and feature 4, you'll get the same result. That is not the same result. There is some changes. But yeah, feature 1, feature 2, feature 3, feature 4 given 1 multiply probability of 1 divide by probability of feature 1, feature 2, feature 3, feature 4. Now for class 2, let's calculate here. Probability of 2 given feature 1, feature 2, feature 3, feature 4 is equal to, we need to calculate probability of feature 1, feature 2, feature 3, feature 4 given 2 multiply probability of 2 divided by probability of feature 1, feature 2, feature 3 and feature 4. So basically, we need to calculate this and this and this. So maybe you will get some value. Maybe you are getting some value here, some value here, and some value here, and maybe you are getting the maximum values here. In that case, you can say for a particular feature 1, feature 2, feature 3, and feature 4, this particular data belongs to class 2 because this value are getting high. So we'll try to write this in Python code, but just 1 minute. Here you can see we are dividing the similar number. So we are only looking for which is higher. So there is no need to divide the same value, because there is no meaning of that. Why? Because suppose 6 is greater than 3. If you divide 2 both sides, still this relation remains same. That's why there is no need to use this number, because we need you already knew we are not looking for absolute probability, we are looking for just to compare these values. So that's why. Second thing, we need to open this as well. So let me explain how we can open this. Suppose you have a probability feature 1, feature 2, feature 3, feature 4, and given 0. Maybe it given sometimes 0, given 1, or given 2. Here you can see given 0, here given 1, here given 2. How can you open this? See, I am putting one assumption here that all feature 1, feature 2, feature 3, and feature 4 are independent. So if these are independent feature, we can, if you are taking that assumption, in that case you can write like this: feature 1 given 0 multiply feature 2 given 0 multiply feature 3 given 0 multiply feature 4 given 0. Actually, I'm taking, if you need to calculate the joint probability of A and B, if both are independent, you can write like this: probability of A multiply probability of B. So I'm using this only here. Okay. So let me delete this. So now we can open this like this also. Now we can open like this also. So basically, now you can write, if you are actually want to calculate probability of 0 for given feature 1, feature 2, feature 3, feature 4, I'm calculating again. So here is the equation we got, but I'm just opening this also. So in that case you'll get like this: feature 1 given 0 multiply feature 2 given 0 multiply f3 given 0 multiply f4 given 0 multiply probability of 0. This is my the final equation, right? Similarly, for this probability of 1 given feature 1, feature 2, feature 3, feature 4, I can write like this: probability of feature 1 give multiply probability of feature 2 given 1 multiply probability of feature 3 given 1 multiply probability of feature 4 given 1 multiply probability of 1. Here let's write the equation for 2. So feature 1, feature 2, feature 3, and feature 4. So here our equation be like that: probability of feature 1 given 2 multiply probability of feature 2 given 2 multiply probability of feature 3 given 2 multiply probability of feature 4 given 2 multiply probability of 2. So this is the my final equation, and I need to write Python code for this. But let me explain something. So basically, we are going to use Gaussian Nape-Bayes method. So basically, Gaussian Nape-Bayes is actually using uh, Gaussian distribution to calculate probability. So what is Gaussian distribution? It's called normal distribution as well. So it looks like this, right? The equation for a Gaussian distribution is e to the power x minus mu square 2 by sigma square. So this is my f of x, right? So x is my value, suppose 3.2 I'm looking for. If I knew mean of that particular data, right? Standard deviation of this data. So it's very simple to calculate mean and standard deviation. So if I looking for probability for this particular point, I just put this value into this equation and I'm able to get the probability. This is called Gaussian probability, right? So basically here we are using Bayes theorem and also the Gaussian probability method. So let's try to do this, right? So first let's try to write a code for this particular thing, and then we are able to do this. So say here I already write one code that is basically the normal distribution probability. So you can see first I calculated the coefficient. So this is nothing but just this one, 1 upon under root 2 pi sigma square. So here you can see just see, if it is square you can write like this also, under root 2 pi. So here you can see we got the sigma multiply the square root 2 into pi. So this value, then we are calculating here this value. So e to the power minus x minus mu square divided by 2 sigma square. Then we multiply both and returning this, right? So this will, we are getting the probability. So I write this function to get the probability. Now let's try to do this. Suppose let's take a number. Suppose I'm taking a value, maybe feature 1 is maybe 2, feature 2 is maybe 3, feature 3 is like 3.3, and feature 4 is maybe 2. Now I want actually to classify this feature whether it's belong to class 0, class 1 or class 2, right? So why I take 4 feature? Because in data we have 4 features. So let me do this. Let me calculate probability for this. So you know already we have to first calculate probability 0, probability 1 and probability 2. Which probability is higher? We can say this feature particular data comes from this particular group. So how can we write the probability? That is very simple. We can do this in a easy way. So let's calculate for class 0 first. So here we have data. Okay. I'm writing a loop for the targets. So let me write this. Okay. So let me write here just I'm writing a number. So let writing a loop. So I'm writing for target in this. Okay. And then I'm taking a filter on data. So I'm just writing data 1, data, and then I'm taking just breaking the data. So here you can see this is target. Let me first write a break and I want to show you this. So let me write this. Here you can see this data already we filter on only for 0. So why? Because we have to calculate probability for feature 1 given 0. So this is a conditional probability. So that's I'm first putting the filter on 0 for this. Okay. Now let's calculate. We have 4 features. So if I write data 1 dot mean, we write just that. So we got all the mean, right? For feature 1, feature 2, feature 3, feature 4. And we can drop target here. There's no need for target. So let me write here data 1 dot drop this target, and let me write comma x is equal to 1. So here you can see we okay, right here in place 2. So it will change in the data in place 2. So now see we are able to generate the feature 1, feature 2, feature 3. So I'm writing like this uh, mean, and I'm writing into the list. So basically if you see this, so we have all the mean value. Similarly, if want to calculate sigma is just a standard deviation. So I'm writing here st1 dot. So we have this. Okay, here you can see we have this mean and standard deviation value. Now I need to calculate the probability. So I'm writing another loop here for I comma j. I'm just writing a simple program so anyone can understand this. I'm not writing, maybe this program we can improve this program, but I'm just writing in a simple way so everyone able to understand this. So I'm writing another loop for I can avoid this loop, but anyway I'm writing this in chip, and I'm taking both the list mean and standard deviation. So there is I'm running a parallel loop for two list. Now I am sorry, we have this feature 1, feature 2, feature 3, feature 4. So can I put this also in a list? So this will be very helpful. So let me write a feature list where we have 2, 3, 3.3 and 2, right? So let me write loop for this as well. So here we can take this like feature, and here we write. Okay. So now we are running a loop. Let me call this function here. So this is my function. So I'm in function. You need to first, here you can see, first you need to pass the data, then mean, then standard deviation. So my data is in this one. So I'm passing this first. Then I'm passing I comma G, right? So what will happen? It will first calculate probability. If you write break here, okay, let me write a break here. So let me print this value. So I'm writing here prop. This is my probability. And let me print this probability value. So if you print this probability value, you're getting probability for feature 1 given 0, feature 2 given 0, feature 3 given 0, feature 4. This is a probability for all, right? Here you can see this feature 1 given. Why I'm saying given 0? Because I took a filter on 0, right? Here you can see we took a filter on 0, right? But we need to multiply this, and we need to calculate, probability of 0 as well. So, here you already know there is only each group contain 50 data, and overall is 150. So probability will be 1 by 3 for 0, even probability 1 by 3 for 1, 2, because there is no every group has same a sample, right? So 50 divided by 150 will become 1 by 3. So that is a simple thing, right? So here we are writing the code and we are generating the probability. So either I can do one thing. Let me write here a list, okay, and let's pin this value, this probability value. So basically all the 4 feature we got here. So if we do like this also, it is working. Here you can see all the 4 probability, right? So let's calculate the overall probability. So I'm just writing here of final probability is equal to 1. Then I'm writing loop for I in, so not I, let me write something else. Either ways, no problem. If you want, you can write I as well. So I'm writing I in this, and then I multiply all the probability. You know why you are multiplying? Because we have to multiply this, right? This one, then this one, then this one. So I multiply this. Final probability is equal to final probability multiply with this I, and then also I have to multiply 1 by 3. Why 1 by 3 multiply? Because we have to multiply with probability of 0 as well, right? Here you can see. So I'm doing this. Let me print this also. So if you print this, so this is the final value. Let me remove this one. There is no need to print this value. So here you can see there's no final probability. I need to do this for, you know, uh, all 3 cases, right? Here we are doing for 0. So let me write this also. Uh, yeah. So for 0, so okay, I'm not just doing anything else. Just let me like do like this only. So here this is for 0. So let me write break here, and let's check this one. So here you can see we got for 0, 1 and 2, and we are getting maximum class 2. So we can say that this value coming from 2. Are you getting my point? So let's take one more example. Let's take from data. So let's try to predict this data. So here we already know this is coming from class 2, or actually this is labeled. But let's try to predict how our model is predicting, whether it's predicting 2, 1 or 0. So let's test our model. So let me take this example 5.9, 3.0, 5.1, 1.8. So yeah, here you can see 5.9, 3.0, 5.1, 1.8. So let me test on this. Yeah, here you can see we are getting maximum probability for class 2, and even in the data is also suggesting this particular features are coming from class 2. So it means we are able to, you know, predict the same class, right? This is from the data. So this is the actually it's called a naive Bayes method, where we try to write a scratch code for naive Bayes. It's very easy to do this. Now suppose you want to use a library for naive Bayes. It's also very simple. So let me read the data again. So here is the data. I'm again just converting this string into the numeric form. So this is my data. Now I want to use directly a library on this, that our famous sklearn library. So here you can see this is the data. I just first breaking into x and y. So these are my feature. This is my target. So I'm just breaking the data. I'm able to break into x and y. So here you can see x will just remove the target. Here you can see, and y contain only the target data. Yeah. Now let me split the data into train and test. Now I'm calling the Gaussian neighbors. You know why Gaussian neighbors? Because we are using Gaussian method to calculate the probability. Here I'm training the data. Let me predict also. So here you can see, if you give any number, you can predict also. Here you can see I'm getting class 2. For even we just for the similar data, we got above class 2, and we are also getting here class 2. So in see, if you are using the this particular library Gaussian base, we are just importing from sklearn, and in that case, you don't need to write all the probability, and even if you don't know how to calculate the probability, you are able to apply Gaussian base, right? But I in this video I tried to explain you how basically we are able to overall calculate the probability. What is the meaning of this Gaussian naive, right? So basically Gaussian naive is just a probability method, right? We try to utilize the probability to find a particular data coming from which group. Even you want to predict for a new features, you can using the historical data. So basically I believe now you're able to understand. So actually using the historical data, we are able to calculate mu and sigma, right? So if you have mu and sigma, and now you have the new feature, you are able to find the probability, right? So if you want to calculate probability of feature 1 given 0, so you know how can do this. If you know mu and sigma for feature 1 given 0, means just filter the data for 0 target. So in that case target will be 0 only. So we filter feature 1, able to calculate mu and sigma. So this we are getting from historical data. Now someone is asking for 3, so we can use this historical data and give the probability for 3, right? So this is called Gaussian naive. I try to explain to you, mathematically, and even see if you're not aligned with maths, even you are able to use Gaussian naive using directly this particular library, right? So you can directly use it. There's no need to write this code. I just write this code to explain you how things are happening, right? Most important thing is to understanding actually how this models works, right? And I believe now we are able to understand this. There are some assumption also in this model, Gaussian naive model, right? So I believe you are able to understand. If you are able to understand, please like this video. Thank you so much.